Happy 420, Mr. Ludvesti.
Yeah, we're getting there.
420 is a magical day.
Why is it a magical day?
For all the people who like marijuana, Mr. Ludvesti. 420.
I don't get it.
420 is like a code for marijuana. I don't know where it comes from, but it's National Marijuana Day, basically. For all those California people out there. And Kobe.
We'll be getting started here in a minute or so. Okay, I think we're going to go ahead and get started. Okay, so let me share my screen with you. So today we're going to continue whiteboarding worksheet 2. And worksheet 2, the last problem we did was, let's see, I think it was number 4. No, it was number 5. Is that right? Yeah, number 5 was the last one we did. And so we're going to start whiteboarding number 6. So problem is I gotta get in, hold on a second. I gotta remember who the groups are because I pre-programmed who the groups were and everything, and for some reason it's not working the way I wanted it to. So, oops, that's not it. So sorry about this. It's going to take me a second. I have to get the groups all. Come on. Oh, let me stop sharing. That way I can assign the groups, maybe. Okay, all right. Sorry, it's taking me a while here. I pre-programmed it and I'm not sure why it's not coming up. Okay, so I have okay, so I tried to put you with your partners, but some of you maybe I couldn't find a partner for, so I put you in a different group. So let me go ahead and open those up for you now. You should be getting invitations, I think.
I got an invitation, but then it disappeared.
Oh, really? Great.
Same here.
Yeah, that was the same thing with me.
Wonder why. Okay, so let me try again. How about now? Okay. Oh, wait a second. So, okay, so.
Mr. Infesti, I didn't get an invitation to a breakout room.
Yeah, okay, I'm working on it. For some reason, it kicked you guys out, so I've got to find your rooms. This is being somewhat annoying. So, Joe, I'm trying to find yours. And I can't find it. Great. Okay, so I'll put Riley in a room then. Okay. That's room 1. All right. Kevin, who did I have you with? I forget.
You had me with Matt Schuler.
Schuler, okay, that's right. Okay, where's he at? Room 4, okay. Joe, I'm looking to find where your room is. I cannot find where Aiden and Mark are at. Where the heck are they at? Oh, they're in room 5. All right, sorry. There you go.
Thank you.
Yep. Christian, you're supposed to get an invitation. You should have got an invitation.
Right. I mean, I went to a breakout room, but for some reason, like, I was sitting there for a couple minutes, and like I was the only one there. So
I think there's somebody there now.
Okay. Well, then, can you send me another invite to that breakout room? Because like they weren't there before.
You can't just go right into it. All right.
No.
All right. 10.
All right. So it's saying I've been assigned to breakout room 6. Is that it?
Yep, that's it. Okay, so I think everybody's back. I want to go ahead and kind of take attendance. So if you could please turn on your camera, even if it's not facing toward your face, and that way we can get a picture. So I'm going to do it. Count of 3. 1, 2, 3. Here it comes. Okay. Let me save that. Okay, thank you. Oh, those are nice pictures. Thank you. Appreciate it. Okay, so does somebody want to share their screen with us so we can see what the answer is? Very bottom, click share screen, then a blue pop-up comes up, hit the share screen again.
We can share ours, Mr. Linfest.
That'd be perfect, yeah.
There we go.
And just walk us through how you get the answer when it comes up for us. You have to unmute yourself. Unmute yourself. So Brendan,
There we go.
Okay.
We did like the right hand rule where it's your fingers point into the page and your thumb follows the current of that wire in the center, and so we got it's pointing up and to the left.
Okay, very good. Now I want to talk about this one a little bit because I think some of you for the last attendance quiz, there was kind of a challenging problem. It was an actual AP problem that Brendan did that exactly right. So when you're doing the right hand rule, your thumb points in the direction of the conventional current, your fingers point in the direction of the magnetic field, and then the palm is the direction of the forces on that positive charge, that conventional charge. But the truth is now we have to start talking about reality a little bit. And the truth is that for charges moving through a wire, it's not really the positive charges that are moving, it's the negative charges. So all you have to think about is, all right, so the conventional charges are moving upward and to the right, which means the negative charges are actually moving downward and to the left. So Brendan did this one totally correct. Now I want to pretend that the question was a little bit different. What direction is the force on the negative charges in the wire, the actual charges that move? So could everybody go ahead and do that with me? So your thumb is going to move in the direction of those charges, which are negative charges, so down and to the left. And then your fingers are pointing into the paper, and your back of your hand, because they're negative, they're going to backhand it. That means those negative charges will end up moving toward the upper left. So that's kind of interesting, is that you're like, wait a minute, shouldn't the positive charges kind of get moved that way? And now you're having like, no, wait a second. So that means the negative charges are also moving that way. And you start having this problem, and you start thinking about that happened on the last SWIC. And what this is showing is that on this wire, imagine the wire was this thick. The negative charges will tend to accumulate on the top left of that wire, and the positive charges are on the bottom right of the wire. Now imagine drawing an electric field in. It always points the electric field always points from positive to negative, so the electric field does point upward and to the left. So it still gives us the same answer. So it's kind of interesting. So anyway, so I'm not sure if you got that one. Maybe you didn't get that one last time, but it's kind of an interesting thing. So everybody give Brendan a hand for sharing that. At the bottom right, there's a reaction thing there, kind of clap, yay, awesome. And then Brendan, if you can stop sharing. Okay, now everybody's gonna start whiteboarding number 7. So I'm gonna put you back in the breakout rooms. Adam, you should get a invitation to join your breakout room. breakout room, excuse me. And again, can we have somebody else that's willing to share their whiteboard? Different person.
I can share ours.
Perfect. And again, Matt, if you can just kind of explain how you figured out the answer.
So using the right hand rule, our thumb is pointing towards us and our fingers point to the right. So our palm is facing up in this direction.
Okay, looks good. Everybody give Matt a hand. Yay. Okay, and if you could unshare. Perfect. So I'm going to open up the breakout rooms again, and you're doing problem number 8 now.
I can share ours this time, Mr. Lundfesti.
Okay. I'm not sure what will happen if you share before people get back. Let's wait a couple seconds here.
All right, I'll wait.
Okay. So are you all done then, Matt?
No, I'm not done. I took a half day today. So,
oh, okay.
Yeah, I'm still working for the most part. I'm trying to get a different job though, so that'll help.
Okay. Is the demand still for what you're doing?
Yeah, yeah. They make medical parts, so
Still pretty crazy. Okay.
yeah.
All right, yeah, go ahead and share your screen with us. Yep. And then explain how you use the right hand rule.
It's not letting me.
At the very bottom, there's a little green button. You click share screen, and then a
Yeah,
blue pop-up will come up.
is that it? Oh, here we go. Sure.
Ah, there you go.
All right.
And then walk
So,
us
yeah,
through
we
how you
said it
figured
was-
that. Yep, we can see it. So just tell us how you did it then.
Yeah. So using the right hand rule, so you point your thumb with the wire towards the top left, and then your hand goes, or like it would go. Since your hand's going out of the page, your palm ends up facing back towards the bottom left, and since it's an electron, it goes with the back of your hand. Not the best explanation. But
Okay. So your
does that
thumb
make
points
sense?
in the thumb points in the direction of the velocity. Fingers kind of point out toward your eyeballs, and then since it's negative, then you kind of backhand it, and so that's why it's down to the lower left.
Yep.
All right, everybody give them a hand down in reactions. Yay. And if you can stop sharing, I think it's a red little, yeah. There.
Yep.
All right, so now I think actually I want to share and talk about this next problem. So let me pull it up here. Okay, for number 9, what this is there's a region in space where there's this magnetic field that's down into the paper. And there's a positive charge that has just entered the field from the left. And there's a dotted line because that is the line that would follow if there was no magnetic field. In other words, inertia would cause it to keep on going that straight line. But what I want you to do, I think I want to go in steps here, is it says place a dot a couple centimeters beyond the original posted location there. So there's number 1. So a couple centimeters beyond that. So somewhere over on the right a little bit. But you have to take an account the magnetic force that acts on this. So it might have some effect to the path that it makes. At that new location, you're going to put a 0.2. And you're going to then figure out what the direction of the new magnetic force vector is on it. So for both of these locations, both 1 and 2, you have to draw the magnetic force vector and then figure out what it does to the velocity then. And once you start, and you're going to keep on continuing that, you're going to do that more than once until you might actually start to figure out what kind of path it's taking. Once you figure out that path, then you can go ahead and continue on and just project what you think would happen in this region. Okay, so continue that process to get the general shape. And then we're going to also answer number 9 at the bottom here, where it says, does the speed of the proton change as it moves along that path that you made? And you have to explain yes or no or why you think that. Okay, so I'm going to stop sharing and let you guys go in your breakout rooms, give you a little bit more time on this one. You guys doing okay? Do you need any more time?
We're good.
Yeah, I think we got it.
Okay.
More cookies.
Are you okay, or everything all right?
Yeah, I think we understand it.
Okay. All right. Hopefully you had enough time to talk about it and kind of draw something. Okay, anybody want to share their answer, their solution, their problem?
Yeah, I can do it.
Okay, go ahead. All righty, and just kind of tell us, it looks like it's a circle. So
Yeah.
just tell us how you went about figuring out the answer here.
So we did the right hand rule, thumb to the right, fingers into the screen, and got it facing straight up.
Okay.
So we moved it right and up a little ways.
Okay.
And in this case, now the velocity was diagonal up and to the right. So now when we found it using the thumb, it was pointed diagonal to the left, kind of pointing to a center. And the third one was pointing straight left. And so eventually it would just be a circle.
Okay, and so I noticed in your answer down below, you say the force is always perpendicular to the velocity. And so that means the speed does not change, but only its direction changes.
Yep.
So hopefully what this is kind of remind you of is the uniform circular motion stuff from last year, where if you think about it, this force is only causing, it does cause it to accelerate, but it's only causing it to accelerate in terms of the direction of the velocity changing. And so this kind of leads into energy as well. Does the magnetic force cause kinetic energy to increase? No, it doesn't. So in other words, a magnetic force can never do work on a particle because it's always perpendicular to the motion. So it's kind of interesting. Any questions on that one? Nice job. Thank you very much, Josh. Everybody give him a hand. Yay. Awesome. If you could stop sharing. And let's see, the next one we're going on to is number 10. And I don't think I need to talk about that one. So I'm going to go ahead and put you in your breakout rooms.
Joe's computer died, Mr. Lonfesti.
Who's dead?
Joe's.
Oh, well, that's because he's outside.
Nature strikes again.
Okay, does somebody want to share their computer screen so we can see their answer? Somebody different?
I can do it.
Oh, awesome.
There we go.
And just kind of walk us through how you figured out the answer.
All right, so your fingers go into the page, and then you have to point your thumb to the right, and then that means your backhand is down. And since it's an electron, you need the back of your hand going down to deflect it downward.
Okay, so you said your fingers are into the page, right? Pointing into the page? Okay, I totally agree. I agree with what you said, but
Mark drew that, not me.
Okay, Mark, what should it be then?
Come on, Mark. It's an X.
Oh, shoot. Oh, my gosh.
It should be an X. Okay, here's the way you remember it.
Oh, yeah, yeah. I was got carried away with the circles. I was like, oh, well.
Okay, well, try to think of it as, you know, the fletching on the arrow. It's getting stuck in the paper, and so you can see the fletching, the feathers. Okay. All right, good. Give Aiden a hand there. Nice. Yay. Yay. Okay, nice. Okay, so I want to go back to that problem for a second. So, so there's the magnetic field. It's into the page. Sometimes you'll see a problem like this, that, okay, here's the original setup, but it'll say something like, there's also, oh shoot, why did I do that? There's also a electric field such that the particle actually goes straight through, so it's undeviated. So it'll ask you, okay, so which direction is the electric field? And I kind of want to show you how you'd figure that out. So first of all, I'm going to get rid of that for a second. The way you'd figure that out is you'd go, okay, well, what direction is the force, the magnetic force on this? Well, that's pretty easy. You can see it's kind of curving downward. So that means the magnetic force must be downward. So FB. If it says that the particle actually goes straight through because there's an electric field that causes it to go straight through, that means there must be an equal and opposite force to balance out, to cancel out the magnetic force. So there must be an electrostatic force upward, so Fe. Now, since this is a negative charge, remember the electric field is defined upon positive charges. So, in other words, the positive charge would feel a force in the opposite direction of this negative charge, which means the electric field is actually, this direction. So that would be the E field. So sometimes you'll see a problem like that where you have both an E field and a magnetic field in, and you have to figure out, okay, which direction would that B field be or the E field be to give you the path that it's taking. Now that's not true in this next problem, but I just wanted to mention it because you'll definitely see problems like that. Okay, so for the next problem, number 11, it's similar to the last one, but now the electron is now bending out of the paper towards you, so it's coming toward your eye, and you have to figure out which direction the B field is. So I'm going to go ahead and open up the breakout rooms again. Oh, I got Joe, I got to put you in room. Hold on a second here. So where are they at? They're in room 5. There you go.
Yeah, my computer died. I don't know what.
You were outside.
Yeah, I'm back inside now.
You should get an invitation. And I think this is going to be the last one we do today. Is Jack sleeping? No, no, he's not sleeping. Okay, all right. He just looks really mellow.
I just woke up.
Okay, so does somebody want to share their whiteboard for this one, number 11?
Oh, we can share it.
Perfect. Go ahead, Matt.
All right.
There's a green share at the bottom. Click on that,
Yep.
and then a pop-up comes up, and click the blue share.
Okay. There we go.
Okay, and then tell us how you'd figured that out. Well, you said it's going downward, so kind of explain how you figured that out.
Okay, so we figured that the magnetic force had to be going out of the page. So
Okay,
we
so
kind of use that.
What part of your hand then is, what part of your hand is toward your face then?
That would be the way I did it. I used this diagram right here.
Okay.
That would be the magnetic force.
We can't see what's on the diagram. Can you describe it?
The direction of the particle is your index finger. The
Okay.
B field is your middle finger, and the magnetic force is your thumb.
Okay.
So the way we did it, we had our index finger pointing forward, which is direction of the charge. Then we're using our left hand, so the magnetic force would have to be going out of the page, which means the B field has to be downward.
Okay, when you say downward, you mean from the top of the page down toward the bottom of the page, right?
Yeah.
Okay. All right. All right, give Matt a hand. Thank you. Yay. And if you could stop sharing, I think there's a red button or something like that. Okay, so I think that's it. Then I want to share with you what else I want you to do. I think I want to look at that problem real quick just to make sure you got, I'm going to kind of draw, I think, the arrow on here. So I just want to make sure you understand that the B field is kind of pointing like that. Okay, so I kind of would like you to finish those last few so we can go through them pretty quickly tomorrow. Also, I would like you to get started on worksheet 3, but on your paper. So I haven't shared it with you on whiteboards because I kind of want to do similar to in class where I ask you to do it at home. Then we quickly whiteboard it together. So tomorrow, or not tomorrow, Wednesday, I will give you links to the whiteboards, but I want you to do it on paper first. So how would you do that on paper? Well, worksheet 3, if you click on the magnetism unit, if you open it up, worksheet 3 looks like like this. And you might have to use Ampere's law, or you might have to use the Bilson equation or the equivalent expression for a charge. So it'd be QVB sine of theta. Or you might have to use right-hand rule to figure stuff out. So I would like you to get started on that as well. And so it goes that far. So we'll be whiteboarding that as well for a little while. And for today, after today's lesson, then I want you to do a quiz. Again, only 4 questions, but not everybody has to do this quiz. The people who actually presented, now I understand they maybe didn't do everything on the whiteboard, they had help, but at least, you know, they were able to kind of communicate for the whole class, and I want to reward them for doing it. And I'm not always going to do it, but today I want to. So Brennan, you don't have to do it if you don't want to. Matt Gilman, Matt Willits, you don't have to. Josh, you don't have to. Aiden, you don't have to. Matt Schuler, you don't have to. Okay, but you can if you want. So, and encourage you to do it if you want. I will give you a bonus. Not a lot of bonus, maybe a couple points. Not that much. It's not that hard. It's the stuff that you've done before from the last one. The code is lowercase r, the star symbol that's above number 8. So lowercase r, star symbol, uppercase T, lowercase w, lowercase u, uppercase y, lowercase g, 7, lowercase c.
Do we have a test this unit or no?
No. We might have a quiz. You know, I gave a test in my regular class right before spring break, and it was a pain to grade. So if I give because I made it open answer, and if I gave a quiz or something like that, it's going to be multiple choice because it's just like too hard for me to grade on the computer. So at this point, I'm not planning on anything. The final exam is your AP test on the 11th. So again, that code is R, star sign, star symbol, uppercase T, W, excuse me, that's lowercase w, lowercase u, uppercase y, lowercase g, 7, and lowercase c. And probably I should talk a little bit more about the AP test. I just want to make sure you've seen this here. It's May 11th. The test for you guys is at 2 p.m., but you're supposed to log in at least a half an hour early, so 1:30 p.m. You're setting up the computer and making sure you can upload stuff, I think. Also, we're supposed to say things that you can still make up from previous weeks, and the only thing you can make up is the last internet assignment. So if you want me to open that up again for you, if you forgot to do it, send me an email and I'll do that. I also sent you an email with a bunch of information. One thing that you should look on, please make sure you read through it. One thing that you should look at on there is evidently the College Board has sent email survey out to each one of you. And I think only a few of you have answered it, like 2 or 3 of you. So the College Board is kind of getting nervous of, you know, what kind of capability you have at home as in terms of computers and stuff. So please answer that email. You might probably isn't your school email, although it might be. It could be your home email or some other you know, look in your maybe junk mail or something like that. They sent it out April 13th. The next Zoom meeting we have is on Wednesday. Any questions? Oh, I need to get attendance picture again real quick. So before you guys leave, let me take another snip. So on the count of 3, I'm going to do it again. So make sure your computer's turned on. 1, 2, 3. Rubik's Cube. Oh, nice. Save it. Okay. Any questions for me? Okay, so thanks. See you later. Bye.